Today, I wanted to talk about real world MCP. Probably everyone in here is here because you have at least heard of MCP. It seems like the model context protocol is everywhere, and every service out there is putting together MCP servers. But at our work in rotational with our clients, we find that the MCP servers that they most want are access to their own databases and getting their own data into these agents to produce actually good generations. And so we're going to talk about using an open source project from Google, MCP Toolbox, about how to set up your own MCP servers around that data source. So this is a tutorial session, and I would very much like if everyone could follow along with the code and try this out. Uh, but there is quite a bit of stuff to download, including the data sets and the code. So I'm going to do maybe 20 minutes of talking to give a little bit of background on everything with MCP. So while I'm doing that, if everyone could go to github.com/rotationalio/mcp-tutorial, that is where all of the code and everything for this tutorial is. And if you scroll down to the README, getting this Docker Compose up dash dash build, once you've cloned the repository, that's actually going to run a couple of scripts that will download the databases and everything else. So that's important to do. And then you can run this bash script to check if the databases are seeded and everything is good to go. And if all of those checks pass, then you are 90% ready for the tutorial. You can set up the virtual environment and all that sort of stuff, but you do Python on your computer, however you guys want to do Python on your computer. I'm not going to specify that stuff, but there is a guide there to get through that. The last 10% is an open router API key. You can use the free models, but you're going to need to connect to a model in order to run the LLM system. I prefer not to run things locally because I just don't know what everyone has in terms of hardware, and not everyone has an M1 or an M2 chip on their computer. So if you could also go and get open router API key, that would also be very helpful for you guys to get. So you guys can work on that while I'm talking, and then hopefully we'll all be ready for the demo and the practical bits for this. Okay, so let's get started with a little context. This is more of a beginner tutorial. So let's first talk about what is MCP. It's technically an open source standard, and it was really designed for connecting AI applications to external systems. Anthropic is really the company that's behind MCP, and they're the ones that sort of pushed MCP out into the world and really worked hard to get this installed into Claude Code. Um, you know, I MCP is an interesting API because it does wrap JSON RPC 2.0 as a communication protocol. That said, if you dive into some of the code out there that exists for MCP, let's just say it's really vibe code, right? It is not the same as other types of protocols like gRPC or even sort of standard REST API things where there's really a formal definition and a lot of tools around it. If anyone here is trying to set up their own MCP servers, I would really recommend looking at Fast MCP. The guys at starts with a P. But it uses Fast API under the hood for this JSON RPC 2.0 protocol. But once you get away from that bottom layer of the stack, things get really, really general, right? And what you're able to do with it and how you're able to do things. And part of that, is just the nature of the beast here, right? What we're trying to do is we're trying to feed context into language models, right? So sequential text generation is a little meaningless unless it's generating something that you want to be generated, right? And so that context, either retrieve documents or some sort of information for that generation, that's what MCP is designed to give the model that information to generate it. But then that also makes the context protocol itself very general and very generic, and also very human language focused. Things also get very confusing with the architecture. So, like I said, MCP was set up by Anthropic. So, when we think about in software engineering, a protocol, we might think about a client and a server. But there's actually multiple parts to this, right? So there's the host, which is the application that maintains the clients and connects to servers. There's the client, which maintains the connection to the server and also to the LLMs. And then there's the server itself, which is the MCP server. So there's actually a lot of moving parts in the MCP protocol. And I think that's the hard part for everyone to wrap their head around. Particularly when you see an architecture that looks like this, right? So here the hosts are the LLMs, or Flying Cursor, or some other application. The client is the piece of software that you write that connects the MCP hosts to the MCP servers. And then so there's like a connection between those either through standard input, standard IO, or via a web service. And then you have this JSON RPC connection between the MCP servers and your MCP clients. And then you can also use standard IO as part of this communication process where you're writing a JSON RPC into a socket, and you have some sort of service that's reading from that socket. So the architecture, I'm going to describe it as fuzzy, right? It's very loose, and it really does create a choose your own adventure situation. And I think that's why when you look at Claude Code or Anthropic, or really anywhere, I'll start to see these MCP registries start to pop up, right? MCP registries to connect your code, because you need to figure out how to set up all of this direction between your various MCP servers. Now, the basis of MCP is this idea that LLMs can request tool calling, right? So tool calling is, if we want to set up a function, like a Python function that the LLM can call, the LLM needs to know what the parameters are and what the function does, and then the LLM can request those tool calls. And a lot of what happens is you have these remote services out there that have APIs associated with them, right? So if we want to give our LLM or agent, our MCP client, the ability to look at all of the repositories or figure out what the last commits are, right? We want to be able to use the GitHub API to do that. And so GitHub might expose an MCP server that tells the LLM about, right, the API. And then with data sources, what we're really going to be focusing on today is a lot of times we might write APIs to connect to our tool calls, but those tool calls just go straight to a database query, right? And so what we're going to look at today is a tool called MCP Toolbox, which cuts out that middle part of the code definition. You don't have to write your own API. We can use MCP to go directly to the database. So at a high level, that's the architecture that we're going to be following. You have to disambiguate, that's what I'm looking for. Disambiguate things a little bit more. We can talk a little bit about what the hosts are. So the model is technically the host, right? Because the model is asking for the tool call, like I just described. And so you need to have a tool-capable LLM. And not all LLMs are tool-capable. Right. So, if you're looking at like Llama CPP or LM Studio or VLLM, you've got to focus on some of the newer models. These are usually like the 8 billion models that have tool calling capability. When you're looking at Open Router about which models you can use, you should see like tools as one of its capabilities. And that tells you that it's a tool calling model. But at the moment, all of the big providers, OpenAI, Anthropic, and Google, all support using MCP. So it's becoming more widely available. I already talked a little bit about the transport layer. So you need something to connect all of these things to each other. Standard IO, right? So this is Linux or POSIX sockets, standard in and standard out. The reason that this is actually the base transport layer is because the original vision of MCP was that this would be like in your IDE, right? This is what like Claude Cursor and Claude Code are all about, is using the standard IO, where you these sort of local processes on your machine. And so you don't really need to connect out to the world in order to do MCP. You can just write between processes that are running on your local computer. I think that was sort of a good idea, but it lacked a lot of foresight into how big this would become. And they went sort of a second direction once they realized that all these service providers were going to provide HTTP calls. Now it's streamable HTTP with server-side events. Has anyone in here ever done server-side events or WebSockets? Okay, a couple of you. It's not that easy. Even in a regular web application, the HTTP protocol is really not meant to do streaming, right? Now we have HTTP2, HTTP3, Swift. We have some other protocols that are better at streaming in binary. But the reason I think that streamable HTTP was a good idea is because if you have a chat client, right, you want sort of this continuous chat between your MCP server and these tool calls. So that was kind of another slightly wrong turn that the MCP development took. And we finally landed on JSON RPC, a more standard HTTP that's a little bit more common. And so when you look at something like FastAP or FastMCP or those types of tools, they really are using the JSON RPC format. And the reason I'm mentioning that is because when you guys are looking at the documentation for MCP, these are all the places that you're going to get confused on. At least that's where I got confused on. Like, how do we implement this? And shortcutting right to the bottom with JSON RPC and fast MCP is definitely the right way to go. Standard in and standard out is more of a specialized use case. That said, almost all of the tools in the registries, at least the older ones, do really focus on standard IO rather than streamable JSON. So we're not quite there yet, which is why today's talk isn't about using something like that. It's about using MCP toolbox. Okay. So let's focus in a little bit on what the code you guys will be writing in. You guys will be writing the client, right, in today's tutorial. So you guys will be writing the thing that connects the LLM to the MCP server. You guys aren't going to be writing the MCP server, and you'll want to connect it to your LLM. So what are some of the client capabilities that you have? And these capabilities are really a way to give your LLM more context or more information. So the first capability is sampling. So sampling gives actually your MCP tool the ability to access the LLM, right? So it's kind of an interesting reverse connection there. So let's say that GitHub has an MCP tool, and you're sending a request to GitHub, and GitHub, the reason it's called sampling is because GitHub might want to like filter down some list or do some sort of classification, but the MCP server itself doesn't have the model to do that. So it's going to come back and request you, the client, to use the LLM to perform that sampling technique. I personally have never really seen this work very successfully in production. So, because one of the problems is that the server, the MCP server, doesn't actually know what LLM you're using, and there are pretty strict definitions of like what's good in terms of a sampling requirement to come back in order for the API to use it. So, I just wanted to throw that out there as a capability that exists, but, it's still not really well rounded out in the community. And actually, I think maybe this whole sequence of this talk is really just to tell you guys that even though MCP is ubiquitous, this is still really early days, right? So if you have someone tell you like, oh yeah, MCP is the standard, the foundation for all, but we're not there. right? We are still trying to figure that out. That's why Google's A2A protocol and some other protocols are coming out to try to solve these things. And then my last slide is on security, which, we'll get really start talking about security when we get into this. It was not thought about at the beginning of the protocol. Same thing here. The roots is a cheroot jail. It's a boundary definition of what is accessible to the server. Roots are really about the standard I/O connection, right? Because if you have a standard I/O connection, you have these processes that can operate on top of your entire computer, right? Your local computer or your local server. And so roots are intended to say, here's the boundaries of the file system, right? So you guys may have noticed if you guys use Claude Code, Claude Code will ask, like, what directory and subdirectories can I go down, right? And that's actually this roots thing, right? You're defining roots for your Claude Code client, not your Claude Code host. The interesting thing here is that it doesn't enforce restrictions. So, like, even though you can define these roots, it's not like a cheroot jail. It's not enforced by the operating system. It's not enforced by the MCP protocol. And that sort of alludes to my continuing points about security that I will make through the rest of this presentation. Elicitation is really the capability that you guys are going to be using, right? It's a structured way for servers to request information either from users or from the LLM or from the MCP context. So this is the slide that tells you really what you need to know specifically about MCP. So we've gone from the host, which is like the LLM side, to the client, which is the code that you write, now to the MCP server, which you may be writing, but in today's case, it's going to be the MCP toolbox. So MCP supplies three things to your client. It supplies tools, resources, and prompts. Tools are the functions that your LLMs can use, right? So sampling, roots, and elicitation, this is going from the MCP back to the LLM or through your client. Tools is going from the LLM to the MCP server, right? So hopefully that's not too confusing, but we're going to be primarily looking at tools. This is the main thing we want. We want to equip our LLM with this tool calling capability. Resources are passive data sources or passive information. They're really meant for the client. They're really meant to tell the client something. Things like what's in the file system, what the database schema is, any types of API documentation. The LLM will sometimes request these resources, but it will only request those resources if they're defined in the tool call, right? If the tool call says that these resources are available as part of the tool call. And then the last thing that MCP servers can provide, and this is not something we will be using today, but prompts are prompt templates, really, but they're ways to tell the model how to work with specific tools and resources. And those are usually generated during like the elicitation process. So again, it's not something that we're going to cover today because it's not a spec that's fully defined and it's not part of MCP toolbox. So we're going to skip the prompts thing. But whenever you make an MCP query, what you're going to get back is these capabilities. They're called capabilities. And the capabilities will have lists of tools and tool groups, resources, and prompts. That's what you're going to see coming back from the MCP server. All right. My last comment on security is that you should absolutely take security seriously, especially if you are going over the internet to any of these types of services. But hopefully what you guys are seeing is that security is not baked into MCP, right? It's not part of it. Most MCP servers out there, like so I mentioned like GitHub or Notion or Salesforce or Google Drive, the security is OAuth, right? That's the security. So it's a user-based token that's allowing access to that MCP server. And so, you guys have all used OAuth before. You're in a browser and you get redirected to the client application, right? And it says, hey, such and such client wants to use your Notion documents, and it wants access to your documents, your folders. It tells you exactly what it wants access to, and you hit authorize, and then that gives back a token to the application for 1 hour that allows that application to act as you, right? And so OAuth is really the only security in MCP documentation that exists, right? There's a couple of problems with that. That's really good for human in the loop type stuff, right? So if you have a human sitting at particularly a browser, right? If you're inside some other application, then it's going to have to open a browser window. If you guys use Claude Code, this happens a lot, right? You'll be coding, and then all of a sudden it asks you to open a browser window so you can do this OAuth authorization workflow, right? Because the token expired, right? You authorized it yesterday, token's expired, now I got to use it again today. It's not great for production workflows, right? Right? Because the token expires, right? If you try and do any types of automation, you need some human in the loop to approve any of this tool call use. So security is really not well thought out. The JSON RPC system it doesn't mandate SSL or TLS. It doesn't mandate any type of authentication protocol or encryption security. The roots aren't enforced on standard IO. So there are best practices, but security is still and continues to be a very big concern when it comes to using MCP in your agents, because as you will see, your agents can request a tool call for anything that you tell them is available, right? And part of what tells them what's available is the MCP toolkit, and there are known attacks where MCP tools have had tool injection that do tool calls that are not what you're hoping for it for, right? They are scary tool calls, and the only thing stopping that is human in the loop if you're using MCP. So prompt injection, all those types of attacks, it's a real thing in this, and you should absolutely take security seriously. And there is no security by default. Okay. Let's move on. So, you can write these different tool calls, like I said before, for us and probably for you guys. The most common APIs that you will write are going to be things that access a database, right? And so if you write an API, you can think probably you guys have all done this in your careers where it's like REST API, you have some object, create, retrieve, update, delete, and that mirrors to some CRUD process on a database, right? That's the API. We're trying to move fast. We're trying to give information to our LLMs. Hopefully, we're primarily doing reads, although there's nothing preventing you from doing writes with MCP. But we're probably doing reads, and we just want to give our agent access to these databases, and that's where MCP Toolbox comes in. So it's built by Google. It's fully open source, and it's an MCP server that allows you to connect to different data sources. So there's 35 to 40 databases. Postgres, Mongo, SQLite, Redis are kind of the big ones, but there are a bunch of others, including sort of the whole Google Cloud database stack under the hood. Today, we're going to focus on Postgres and Mongo. So very standard situation. We have a relational database, and maybe we have a document database. And we want to give structured information back to our agents from these databases. This is fundamentally different from RAG, right? This feels like and kind of looks like retrieval augmented generation. And there's really nothing stopping you from doing some kind of retrieval augmented generation. In fact, we tend to use pgvec with Postgres to do RAG using MCP Toolbox. So you could do RAG with this, but you can do a lot of other different stuff. The most common example is like retrieve flights, right? Like do a select for flights that match certain criteria. That's not semantic search, right? That's just a retrieval, like what exists, what's coming up in this time range or something like that. And more often than not, those are the types of queries that you're trying to put into your LLM. right? Very simple selects, or different types of filtering, and not RAG. So we're not talking about RAG. You could do RAG, um, but we're really talking about really being able to query the database more effectively from the LLM. So how does this work? Well, the MC Toolbox is a server that's going to be running, and you have to tell the MCP Toolbox what it can do using a YAML file, right? So you give the MCP Toolbox a YAML file, and then you can run it, and then the MCP Toolbox itself will connect to your database, and then produce these capabilities, right? It'll expose the tools and resources, and if you did prompts somehow, the prompts to your clients so that you can start connecting with your agent. And again, if you have a pre-existing database, this is really a quick and easy way to give your agents access to the database. So that's what we're going to be looking at today. That's sort of my brief overview. We're going to go ahead and take a look at some code. We're going to be using an Olympics data set. That's from Kaggle. So we have 127 years of Olympic results. That's going to be going into our relational database. And then we have some Wikipedia articles for our unstructured database that we're going to be putting into Mongo. And we're going to be handing sort of Gemma, the ability to query Postgres and Mongo via the MCP toolbox. And we're going to do that locally using Docker Compose. The main things that we're going to explore are an inference loop, and doing tool calling within the inference loop. I'm going to have a couple of demos, and then I'm hoping that you guys can try a couple of things and write a couple of prompts and tools yourselves. Any questions or thoughts before we continue? All right, plus one slump. Love it. Okay. Please.
Do you have any recommendation? But there are a lot of MCP servers on the internet.
There are so many. Yeah.
Any recommendations for how to ensure they're safe to use? And just rely on the fact that they're from a repeat source.
Yeah. So the question is, there's a huge number of MCP servers. Are there any recommendations for what's safe to use? My first recommendation is, by default, they're not safe. Right. So my first recommendation is treat them as unsafe, even if they're from a reputable source. The issue here is that because there's no standard for security, the MCP tool is pushing that security onto you, the user. Right. So by default, you have to assume that they're not safe. And so what that means is you have to ask this MCP tool, what is the security context that you're asking for? And like I said, most of the time it's OAuth, right? It's a human in the loop, very user specific orientation towards OAuth. I am looking for keywords about TLS required or TLS enforced, the omission of standard IO. Those are two good signals that there's some sort of security protocol in place underlying the hood. Read only is also a good signal, right? So if you see anything that says read only and it doesn't provide any write, that's probably a good signal that they've tried to omit some of the more bad things that can happen with the MCP server. But unfortunately, it really is kind of a choose your own adventure situation right now. The best way to get control of the security context is by running your own MCP servers rather than on a provider-based MCP server. So, for example, if you need to access GitHub, right, at some point you're just gonna, you might start out prototyping by using GitHub's MCP tool. But at some point, if you're going to do this for real and for production, you're going to want to set up your own MCP server with fast MCP with your own GitHub tokens embedded into that MCP server in your own security context. That's just kind of the way it is right now. Yes.
Might be good to point out that this MCPs are a favorite supply chain hack vector that
like the software supply chain.
Yeah.
Was it Trivi last week that hit MCP?
Well, yeah, that's even more, yeah.
Yeah.
And it's an amplifier of the supply chain attack, spreading.
That's a really good point. Thank you for pointing that out. So yeah, MCP is an absolute amplifier of software supply chain attacks. NPM is sort of the root of all security problems, or 90% of security problems on the internet, and a lot of this stuff is implemented using NPM libraries. So I just want to throw that out there. And the reason that NPM is so bad is because NPM really has huge dependency chains, right? So if you compare NPM dependency chains to Python dependency chains, are usually 50 to 60 dependencies longer than Python chains. And so I think that's what you meant by the software supply chain. And there was an attack on a lot of MCP systems a couple of weeks ago. I think it was called Trivy. Do you remember what it was called? Trivy or Trivy?
That was the root of it, and then it attacked, was the other one. It also exposed the even, yeah, I mean, they've been going for the most used NPM packages.
Yeah.
Yeah, it was a really nasty one.
Yeah. So, and I mean, they're just going to keep coming up as the different types of prompt injection for getting better. Because again, this is not a discrete software system that's calling these tools in a very specific way. There is some LLM that's requesting these tool calls, and the LLM is the one that's providing the parameters to those tool calls. So those parameters could be coming from some type of prompt injection. So you don't have a whole lot of control. While we're on this topic, the other very important place for security here is with input and output guardrails. So like Llama Guard or the Bedrock Guard, those different types of prompt injection tools are just kind of an absolute must if you're using MCP.
Guards. Say it again. What were they?
The Llama Guard guardrails, or the Bedrock guardrails.
There's also a really good article, search lethal trifecta.
Lethal trifecta.
That it gives practical advice. So basically, I have an LLM that has access to secrets. I have an LLM that has access to the network, and I have an LLM that's access to general content on the internet.
Yeah.
And if you cut off any one of those three, then you can't be problem injected, or at least it can't exfiltrate the secrets. So basically use a sandbox. You can hard codes built in the sandbox will through the network access default will ask you to access anything on the network.
Yeah. And I don't want to be a Debbie Downer. I mean, really big opportunities here with MCP, which is why you guys are all here. But I just want to make sure that that you're swimming in the ocean and there might be sharks in there. And it's important to point out. And so there's no tripping hazards. All right, has everyone managed to at least clone the repository? Let me just quickly show you guys what's that. So when you run docker compose up build, then you should see down here, this is my docker compose terminal. You should see Mongo running. And you should see, if you scroll, this is all the log messages. I started this a little while ago. You can see the MCP toolbox running. That's toolbox 1. And then you should see Postgres. And then there's another script called seed. Seed is what's going to be downloading the data sets and installing them into your database if you've run this Docker Compose file. The test databases script. So if you run scripts, test databases, then this is what you should see, right? You should see all checks finished okay. If you see there's no rows in the database, then that means that the seed script either failed or it didn't download the databases. You can reset everything by running this verify stack.sh. This will bring your Docker Compose down. It will delete the Docker Compose volume, and it will attempt to reload the databases in a more manual fashion. This is verify stack. And then if you do run this script, you'll have to bring your Docker Compose back up because it will go down. A couple of quick debugging tricks. If you guys aren't used to Docker, you can do Docker Compose PS. This will tell you what's running. And so if you see that Mongo is running, Postgres is running, the toolbox is running, then you are good to go. Everything is running. And then if you do Docker compose down -v, that's sort of the hard reset. It'll take everything down. And this is all has to be in the local directory of the repository, right? There's this docker compose.yaml. That's right here at the bottom. That docker.compose.yaml is where all of these service definitions are. So, we're doing hosts and clients and servers, and there's a lot of networking going on. We're using Docker Compose to do this all. That's beyond the scope of this tutorial, but I want to make sure everyone is set up for success here to run it. We have this demo MCP toolbox notebook, and this is where everything that we're going to be doing today lives. There's two branches. There's the main branch. I'm on the main branch right now, and at the end, there'll be some places where you guys can try this yourself with a couple of prompts and things like that. There's also the answers branch. So if you guys just want to see the full notebook, fully completed, that is in the answers branch. But we'll go through this all together. I'm going to skip the Python stuff and the configuration stuff. Hopefully you guys can figure that out. But if you have any problems, please let me know. So what are we working with? So our data set is 126 years of historical Olympic data on Kaggle. So we're going to write prompts. I was thinking like maybe we could be like a sports journalist that's either commenting on the games or writing articles about local games, and we want to have this sort of historical context, and we can prompt and ask questions of our database to get this historical context and to do it without search. But really what I wanted to make sure is that we were looking at both structured relational database and a NoSQL database and how to combine them together using MCP Toolbox. So we have 4 tables in our Postgres database. We have the Olympic Games, which is, every 4 years. So year, host, city, country are in that table. We have athletes, which has the name, country of birth, and some lightweight information. It doesn't have a lot of biographical information under the athletes table. We have countries, which uses the National Olympic Committee. So anytime you see NOC, that's National Olympic Committee, the country code names. And then we have the events, which contains all of the events for all of the athletes and their results. So that events is sort of the main table that joins all of the other tables together. But you can see probably all of these things are very important to any LLM query that you might make about the Olympics. Then for the Mongo database, we have the athlete biography, which has far more information than the athletes table in the relational database, and that's completely unstructured, just from Wikipedia. Just talks a little bit about the athlete and what we've done. And then we have a little bit more detailed results of the Olympic events in sort of natural language, these documents about the events in this Olympic event results database. So let's talk about the first thing that you need to do. So with MCP Toolbox, what you need to do is you need to define YAML or a series of YAML files to tell MCP Toolbox what its capabilities are, right? So if you spin up MCP Toolbox, it doesn't just provide complete access to a database. One of the misconceptions is that this is like a text to SQL system. It's not. NoSQL is generated by the LLM or else otherwise. Text to SQL is actually an elicitation capability, right? So if your Postgres database wants to generate a SQL statement, it can elicit your client to do some type of text to SQL. That's not what MCP Toolbox is doing, right? These are very specific queries that you're making in the query language of the database that you're connecting to. So the first step is connecting actually to the data sources. So we define our sources using YAML, a list of YAML objects that have this definition. We need the name of the database, the type of database it is. Those types all come from the MCP Toolbox website. And then we need the connection details. As you can see, most of the time we're pulling these values straight from the environment. If you're configuring this in production, you can use other types of like key cloak injection or anything else you want to set up the configuration, but you have to set this up. And for the most part, let's see if I can bring up the sources file. All of these environment variables are in your .env.template folder. They're all pointing to your Docker Compose locally. If you need to change anything, copy .env.template into .env, and then you can change things, and the .env file will be loaded by Docker Compose and by the toolbox, and it will populate these files. Okay, so that's sources. That's generally the first step. If you guys want to add like a SQLite database, if you download a SQLite database from the internet and you want to add that to MCP Toolbox, then you would add that source to that sources file and then restart Docker Compose, right? Because the sources definition is loaded at runtime, like when the MCP Toolbox starts up. So you're going to have to reload Docker Compose in order to change anything inside these YAMLs. The next step is tools. Right, so the tools are where we put our SQL code here. So you can see this is a country search tool, right? So the name is PG Search Countries. The type of this tool is PostgreSQL. That just tells MCP Toolbox what kind of query this is. You can also do Postgres PG SQL. So if you wanted to use like if statements or conditionals inside of your query, you can use PG SQL instead of straight ANSI SQL. And then you have to tell the source, right? So the source here, Olympics Postgres, comes from this definition up here where we said this is the Olympics Postgres database. So that's how the query is matched to the source. Now, the sort of most important things here are the descriptions and the parameters. So the description is actually part of what gets into the capabilities. So remember I said the MCP server serves these capabilities. It tells the LLM what tools are available. I'm going to have to use some imprecise language here, but the LLM chooses what tools it wants to use based on the description, right? So if you think of the LLM as a natural language understanding component to this, that description is what it's using to match its, the initial prompt to the tools that it wants to use. So for example, if the prompt says something like, give me all of the countries that had a badminton winner between 1950 and 1970, right? The MCP server or the LLM might decide, okay, well, I need to search for a list of countries, right? Like that's kind of the first step in me fulfilling this query, right? It's my list of countries. And so this search by countries by name fragment and not codes, that would be what the LLM might decide to use. The parameters is the parameters that go into the query. And so the parameters are going to get inserted in Postgres using this $1 and $2. So these are ordered positional parameters, right? So name fragment is going to be $1. If we added another parameter to this LLM list, that would be $2, and so on and so forth. Now, your database may do escaping, it may not, right? So you will want to ensure that to prevent SQL injection attacks that you're doing escaping of the input, which means ensuring that's surrounded by quotes and that there's no Bobby drop tables here going into this parameter so that your LLM can SQL inject your own database. In Postgres's case, this $1 system is doing quote escaping on the input. So that's good news. If you're using a database that doesn't do quote escaping, MySQL, then you want to make sure that these parameters are quote escaped before you put them in to the call. And you'll see you actually do have control over what goes into this. So even though your LLM might say, this is the parameter I want you to put in, you still have the control of dealing with that parameter some way. So you could quote escape it directly before it comes here. The description of the parameter is actually also very important, right? Because the description of the parameter is going to tell the LLM how to format this string. So in here is just, the case insensitive part might be a good thing to put in here. Name fragment is interesting, right? The name fragment might tell the LLM that I could just search for, anything that starts with United, right? United Kingdom, United Arab Emirates, United States. It could just be a fragment, or I could search for Trinidad in order to get Trinidad and Tobago. So that might be something that the LLM uses. Again, that's the part you have very little control of, is how the LLM selects what tool it uses and how it decides what parameters to put in there. But the descriptions are the part of control that you have, right? I strongly recommend that you make these descriptions natural language, human readable descriptions that are well structured English sentences, right? I very much recommend that. And the reason is because that's what the LLM is trained on, right? The LLM is trained on full sentences. So the LLM will do a better job matching if you have, a very human readable description. I tend to make my descriptions 2 to 3 sentences, not longer, not shorter, right? The first sentence is really like, this is what this does. A second sentence might be, this is when you want to use it, right? And a third sentence might be, and this is how the results are returned, right? So that's usually the frame that we take in these descriptions. And then with the parameters, you do have some type information here. So, you can say it's an int, or it's a string, or it's a bool, that kind of stuff. But if you want to do any sort of, the LLM is not going to do validation for you. But if you want to put any sort of parameterization in here, that's got to go in the description, right? So, for example, you might want to say something to the effect, like, if it's an email address, this should be a well-formed email address with a complete domain and an @ symbol, right? You might just want to put that in the description, because the LLM might be able to sort of see, like, oh, this parameter isn't an email address. It might choose to not use that query as a result. Or if it's a number, this should be a number, greater than 1, less than 5,000. It should not be negative. That's the type of stuff you want to put into these descriptions. And it helps the LLM, especially the instruct LLMs and the chain of thought LLMs. Those are the ones that do best with these descriptions and that validation kind of language. The name of the parameters is also very important. This is one of the hard things that we have. What you put in here, so the name of the tool and the name of the parameters, that's actually what the LLM is going to give back to you. So you, as the client writing this client code, you also have to know all this stuff, because you have to do the mapping from what the LLM requests to the tool itself. So because you have to do that mapping, you either have to do something automated, and we're going to see a couple of helper functions in a bit that automate sort of this process of doing that mapping, or you have to manage that yourself inside of these tool calls. And then the sort of other key component here is obviously the statement. So you can put any valid SQL query here. In this case, we're using I-like. So this is the case insensitive matching. The percent symbols are the substring to have that sort of insensitive like matching here. And we're joining them with the double pipe operator in order to connect them to the parameter, since there's no string interpolation inside of Postgres. So that's what that string is doing. Okay. The annotations are hints to the toolbox, to the MCP toolbox server itself. So what kind of tool is this? So read only, this is true. This is only a select statement. There's no update, there's no insert, there's no delete or drop. So this is a read only. That's a hint to the MCP toolbox server. You can do that to filter things like, give me only the read-only tools, right? Because you have to give these tools to the database. So these annotations don't go to the LLM, right? These are hints to you and to your client program, so that you'll see that, for us, when we have these MCP toolbox definitions, they're usually very, very long, right? Because we have a lot of very specific selects, but, every type of query here, like, let's say that we want to filter by continent, right? That, where continent equals $2, that's another query on top of this query. So you often have a lot of very similar queries. And so these annotations can help you sort of manage and filter those tools inside of your client. The destructive hint, destructive usually means that it's an update or delete, right? So you could actually edit or delete something from the database. Inserts aren't usually considered destructive, even though that's a write. So those annotations are just hints about what this query can do. I talked a lot about managing, these tool calls and the lots of tools that you have. So another way that you can manage things inside of MCP Toolbox is using tool sets. So tool sets allow you to group all of these tools because, again, we're going to hand them off to the LLM. So we're going to declare 3 tool sets. You can see this in the YAML files. So Postgres only. So these are only the Postgres tools. Mongo only the Mongo tools, and allows us to differentiate what we're giving our server, or we could do combine all of the Postgres and Mongo tools on one list. In a real world database, you might see, Postgres underscore schema name underscore all users, right? Postgres underscore schema name underscore admin, right? Like, so you might see groupings like that sort of allow you to connect to different users your database with what's allowed. So MCP clients, our client can fetch the subset of tools that are relevant to those specific tasks. And that's a very important piece of this because if you inject more tools into an LLM call, you're going to be increasing your token count. So if you are at all price sensitive, you really want to identify exactly the tools that need to go into the LLM query. And actually, I'm hoping that I'm going to get an error later on that's going to tell me that my context window is too large, right? Because I've exceeded the token count. And so we want to be able to manage that by really only specifying exactly what tools can go into this LLM call. Finally, prompts is beyond the scope of this particular tutorial, but this is another thing that you can define with MCP Toolbox to give it sort of specific prompt templates. And there are some examples if you guys would like to look into a little bit more, but there are no real resources in the MCP Toolbox. There's no way to really expose a schema using MCP Toolbox. I personally have not used MCP Toolbox for text to SQL. So text to SQL is where you might want to have the schema exposed. We tend to write our own fast MCP tools anytime we're doing text to SQL. So I would say that this tool is not the right thing for text to SQL. This is for very specific queries, right? You guys are writing your own queries. All right, so let us get into this and take a look at all this stuff. So the first thing that we're going to want to do is we're going to start to write the client program. So this notebook is our client program. And what it's doing is it's going to wire together the LLM, right? So we're going to put our prompt into the client, and then that prompt is going to go to the LLM along with tools associated with that prompt. The LLM is going to request tool use of the client program, which is the notebook, and the client program is going to execute those tools on MCP Toolbox. So this notebook is sitting in the center of the hosts and the MCP servers, and it's going to be managing this entire process. So the first thing here is we have to have some type of configuration. So this is a very standard configuration system that we have. We're going to be using the OpenAI API to make our LLM calls. I'm going to say this with an asterisk. I have yet to encounter an open router LLM that doesn't support the OpenAI API. So Open Router will do translations of the OpenAI API into the API specification that's required by the LLM. So we're just going to go ahead and use the OpenAI API. We're going to use .env to load the environment variables from our .env file. And then we're going to use this toolbox core in order to connect to our MCP toolbox to get all of these tools and capabilities and definitions into our client. We have some context, max tool rounds. That's going to come up in a little bit. And then we're going to use a data class for our settings, which is a pretty standard way that we configure settings in our environment here with the API key, the base URL, the model, and all of this stuff is just going to be coming from your environment, from these environment variables. If you would like to change anything, you can either change the defaults here, or you can change them in your .env file. And then a couple of little helper files. So I'm going to run that. Hopefully that all runs well for you. So let's talk about definitions. So one thing that we have to do is we have to give the LLM data in JSON, and our tool definitions are in YAML. Now, we could just call the MCP toolbox tools API and do this all of ourselves, but sometimes it's a little bit easier to just do a mapping yourself. So this first function takes the toolbox types and converts them into JSON schema types. And then we have a JSON schema definition that we've got here. So really the only real change is that floats have to be called numbers in this. But depending on the syntax that you guys are using, this helper function, we just went the full way. So what you're going to see is that we're going to give it a toolbox tool, and we're going to output this dictionary in this JSON format stuff. So I think that reading code is even more important than ever in the age of generative AI and code gen. So we will go through this, but we're going to go through all of the tools that are the input to this function, and we're going to figure out our properties and our required properties in this tool. So the tool is going to give us this underscore params property. We're going to get its name, and then we're going to put together this JSON schema properties list. We're going to map the JSON type to the param type from the the MCP toolbox, defaulting to string, and then we're going to use that definition from our YAML file and append it in. And then our output dictionary is going to be a list of these JSON objects. And this is what a JSON schema looks like, right? So you have, type function, and then the function is going to have a name and description, and then the parameters that can be given. And in this case, we're going to say there's no additional properties. We're just going to default it to that. So this is the OpenAI tool calling spec, which is a JSON schema of its own. And so we are producing that spec from the MCP toolbox tools. But because hopefully you can see that because we have to do all of this work ourselves, we have the opportunity to do any type of injection that we want in the MCP toolbox. So this happens if you're using some global MCP server. You might want to edit this description with some information of your own. For example, the description might say what this function does. You might want to add the why, right, or the what it returns, or how it does it to this. So we talked about those 3 sentences that you want to put in all descriptions. Scrolling down, the key thing to remember again is that the agent does not run these tools directly. What it does is it will return a function.name and function.argument for every tool that it wants to use. And so we need to make sure that we understand what that function.name to function.tool mapping is. So this tool by name is just a dictionary that maps the tool name to the tool in the toolbox tools. So another little helper function, and I had mentioned that earlier, we need to manage what those names are in that YAML file with the call, the callable that we're going to have to execute. So this is just an automatic way to do that. So you can either do it automatically by listing the tools from the toolbox tool, or you can keep some other definition, like a hard-coded definition if you prefer, depending on what you guys want to do. Lastly, we're going to set up our client to connect to OpenRouter using the OpenAI API. And so this is where we're injecting your API key, the base URL. You're just going to use OpenRouter here. And then we can add some other headers here to identify our application. This is just best practice, for sending data into an OpenAI client. Nothing real special there. All right, so now let's start to wire this up with a prompt. So we're going to be using the chat API, which I'm going to admit is not my favorite API. I think that chat was extremely important to launch generative AI into the real world. Chat is an interface, right? So I'd say prior to Chat GPT 3.5, everyone was just kind of like, why would I want to generate text? I don't get it. And then they produced chat, and chat's an interface. And so that interface allowed us to check with these LLMs, and that sort of allowed us to understand what LLMs could do. But I would say that in principle, chat's not what we want as an interface, right? We want to create workflows and automations, not chat systems. But because of its popularity, and because that's what unlocks LLMs, this is sort of the main API that has sort of the most functionality in it. I strongly recommend that you use the responses API any chance you can get. The reason that you may not want to use the responses API is because the responses API doesn't have the full chat functionality currently. One thing that we're going to be doing with the chat functionality in this case is chat, you give the entire history of a sequence of messages to the LLM. And so in this chat, it's going to be one response, but there's going to be a chat between the LLM and the MCP toolbox. So anytime the LLM wants to make a tool call, we're going to do that tool, and we're going to append the response as a message to the chat, and then go back to the LLM. Okay. So one thing to note that's very important is that you're going to be making multiple LLM calls here, right? So this isn't, you might think, okay, well, my prompt is only 500 tokens. Why did I just spend 20,000 tokens, right? It's because you're going back and forth. And every time you're going back and forth, you're adding the outputs of your tool call to this chat. And so you're always going to be increasing that token usage. And that's where this max agent tool calls round variable comes in.
It uses caching, right?
The LLM or your client?
On the LLM's side, you have normal tokens and you have cache tokens.
Yes. Well, but that depends on the LLM you choose.
I'm just wondering, like, every time you send the whole message history, I'm wondering if, like, because it's redundant, it's not going to change all the way till the last time you send the whole thing, right? Except the new part.
The token count usage?
Messages.
The messages, yeah.
That there's only you're always adding new messages, but the old ones aren't changing.
Right. You're adding new messages and the old ones aren't changing, but
So you said 20,000 tokens, but like really 19,000 or whatever are cached. So the LLM has already processed it. I don't think those are reprocessed when they're sending the whole thing.
that depends on your LLM, I think.
Because otherwise it would be insane. Like the cost would be insane. Like imagine if you have 500,000 tokens already in your messages, and now you send one message. You're not going to process the whole.
I see what you're saying. Yeah, no. So caching does help, right? But like I said, it really depends on the LLM, right, and what it's doing. So, but I'm really maybe talking about the final token count, right? The final token count is going to be the length of the entire token count, right? So, I was saying your first prompt might have been like 500 tokens, but it's going to end up as 19,000 tokens, right? As you keep appending these messages to it.
Yeah.
So maybe not 19,000 times 5 tool rounds,
But the network,
but it will grow.
the network overhead is still there, though. Like,
The network overhead is certainly still there.
yeah, it's kind of crazy how they did it. I guess the responses API doesn't have the same problem.
No, responses API is one shot. Yeah. So, or well, two shots really. So with responses, it's like you will get back like a list of tool calls. So one shot to send the initial thing to the LLM, and it gives you a response back, and then you do the tool calls and you send that all the way back. So it's usually two shots with responses. But anyways, I was gonna say this is where this max tool rounds comes in. Is potentially you could get in a situation where the LLM just keeps asking for tools over and over and over again, right? For every thing that you put in, you have to decide when to stop. And so we're going to decide to stop after 16 tool use calls requests. We're going to be done. Like that's too many tools. We're going to cut off there. So we're kind of going back and forth with this chat with the LLM. That's okay. So this is the initial messages prompt. So what this is going to do is it's going to create our messages input. So if you guys are used to the OpenAI API, you have to have a list of these dictionaries that have a role and the content here. So we're going to have the system text and the user prompt, and that's going to be the initial thing that we're going to put in here. And then this is interesting. What we're going to do is we're going to append a cap to the system prompt. We're going to say, hey, LLM, you can do at most 16 model turns to include tool calls, right? So we're going to try to push that back to the LLM. It's not enforced by the LLM, but we're going to hope that the LLM uses that in its requests back to us in terms of tool calls. All right, so this is the call. So we're going to, this is just a quick function in order to call the LLM. So this is our OpenAI client. We have our settings, our list of messages, and then this is kind of the interesting thing. This is the tools that we would like to pass to the LLM. Tell the LLM these are the tools available to you during this single round of calls. So we're going to use the chat completions API, the model that we're going to be using. This is coming from our settings, right? So this is where we say what model we want to use. The messages are going to be the list of objects that we just created in the previous initial chat, along with any appended tool call messages that we're going back with it. And then we're going to specify tools. And remember, the tools is that JSON dictionary that we put together in the tool mapping, right? So where we said, what's the type, it's a function, here's the description, here are the parameters. That JSON dictionary is what's going here under tools. And then we're going to say tool choice is auto. So we can also have text only, call tools, or mix. So we're going to, you can parameterize what the model is allowed to do in terms of its choice. Coming back to you. And all of those parameters are documented. This is all very bog standard OpenAI API specification right here. In this next function, what we're going to do is we're going to append our tool calls to that initial message list as the LLM requests those tools to come in. So the role that we're going to use is assistant for this. So the roles are system, user, assistant, and then developer is kind of a new role that's come up with OpenAI. But your tool calls are going to be the assistant, and then we're going to add the message.content and then the tool calls that came back from this messages list. Where's TC coming from? Oh, 1 second. I lost it right here. Oh, sorry, TC is right here. So from the message, we have the tool calls that came back from the LLM. So we're going to reply to the LLM. Here is the content from our tool call, and here are the tool calls that the LLM requested. That way the LLM can map what it requested back to the responses that we made to it. So that's what we're doing. We're just appending the responses back to send it in.
I have a question.
Yeah.
Do you also have to append so when you pass the whole messages back to the completions API, You also have to append the the prior responses from the LLM as well, not only the requests. I'm not talking about tools like regular.
Yeah, right. Yes, and that's actually exactly what this is doing. So this is the response from the LLM.
That's only for tools, right?
Well, that's the only response that we're expecting if we're appending assistant messages in.
So what if I'm not using tools at all? I'm just curious, like in general, don't you have to don't you have to send the whole conversation back, including the prior answers,
For
like to continue the conversation? Like,
oh, I see what you're saying. Yeah, I guess we're just thinking about one prompt, one response, right? We're not constructing a conversation with the user. When the user gets to put it in one prompt, then we're iterating on this tool calls loop, and then we're giving our response to the user.
okay, got it.
Right. And so then if the user makes another prompt, I personally would not include the tool calls from the previous prompt chain in that. I would just include the user chats and the response from the LLM back. Does that make sense?
Yeah, that makes sense.
Yeah. So you could basically, that response becomes the assistant at that point. So the final response from the tool calling output becomes the assistant in the chat. So you kind of have to have two chats going at the same time.
Yeah,
Does that make sense?
it's kind of a choice though, right? You could include it for whatever reason.
You could. I don't know if it would help.
Yeah.
Right. So like think about it this way. Like let's say this is, we made a call. Let's see what the prompt is down here. So let's see, prompt A, choose a Summer Olympics game held between 1992 and 2020, and choose one of these countries to focus on: the United States, Australia, Japan, France, or Kenya. Who won medals for that country at those games? Any sport. Use the data tools. Mention a few medalists with a line or two from their biographies when you can, and cite athlete IDs from the tools, right? So that's our sort of initial prompt that's going into this, right? We would expect this, this prompt would go in, it would start using the tool used to call the database a few times, and then we would get the output response from this, right? So at this point, what you have is one chat sequence with this system prompt, and then this user prompt, and then you have a bunch of tool call assistant prompts that are appended to that chat chain. And then if the user makes another prompt here, another request, like, can you tell me a little bit more about, athlete, two, right? You would have to decide, does that assistant tool chain matter here? Because that assistant tool chain was probably country lookup, event results lookup, medal lookup. It might not have anything to do with this, but you also have that full output that was based on those tool calls.
Yes.
And so if you provide all of those assistant tool calls, you still have the context of what the user is experiencing from the chat.
Yeah.
So that's why I personally tend to align the tool calls from the chat for the follow-ups.
Okay, got it. Yeah, I can see why that might be for.
Yeah, and you're trying to avoid confusing the LLM. I think a good rule of thumb is treat the LLMs like a human, right? And a human who has like a better memory, maybe. But if you start giving too much information to the LLM, that's when you start to get into confabulation territory, right? Because it might confuse the instruction, right? And I personally think that LLMs are best for instruct type requests, right? Like this, right? Choose and list, right? That's kind of an instruct type prompt. That's what most of us do, rather than generation type prompts. And if you confuse it, then it will go off the rails at that point. So less is more, or more focused is more when it comes to this. And the tool calls that came before are not usually focused on what the second one is. Plus, that second prompt will probably also cause tool calling, which is now also getting injected into that chat chain.
And yeah, I think you have to be careful because you can hurt the caching. Like if you don't send the whole conversation, including the tool calls that the agent made, not only the tool responses, and then you keep appending this new message array which has things missing, and then I think it might affect caching and then the costs go up. But I'll have to look that up.
Yeah, well, that's a good point. Yeah, so if I spend caching, yeah. But and again, this is why I tend to prefer the responses API. Absolutely. Anyway, we only have 15 minutes left. I'd like you guys to take a crack at this, so I'm going to go ahead and run this particular prompt that we just looked at, and I'm hoping this errors. Oh, it didn't. But you can see here we have, for the 1996 Summer Olympics held in Atlanta, the United States won numerous medals, notably in softball, swimming, athletics, other sports. And then it gives us Laura Berg, Justin Hewish, Lindsay Davenport, Gary Hall Jr., Michael Johnson, and some of their other kinds of things. And so what we can also do is, if you guys would like to see the tool calls, we can add this verbose flag, which I'm going to do right now. But you can kind of see how that probably made a lot of tool calls. So here we have tool call, PG search countries with, so this was the first tool call with name fragment United States. The tool results was NOC USA, country United States, NOC ISV, country United States Virgin Islands. So that's what was returned from that tool call. Then we had list games by year min 1992, year max 2020. Those are the params. So that's we got from the prompt. And then here are the games that were returned. And then tool call 3 was PG medal events for country. So the NOC was USA. The year was 96. Tool call, so it only did 96. That's interesting. Tool call 4 was a Mongo tool call for Mongo athlete biography with athlete ID 1352, 1372, 2724, 5123, and so on. And then we have another tool call. Oh, these are the tool call results. So these are all the biographies that came back. And then on turn 5, in turn 5, we had the result reproduce. So no additional tool calls were requested on turn 5. So turn 1 was 1 tool call with the PG search countries. Turn 2 was 1 tool call with list games by year. 3 was medal events per country. And again, this was 1 tool call with just USA and just 1996. So this could have been a problem, right? Like, how come it didn't look for 92, 96, 2000, 2004, right? Just did 96. It skipped the US Virgin Islands. I don't know if that was a good choice or not. But then tool 4, this was sort of the interesting one. This is multiple tool calls, right? 1, 2, 3, 4, 5, 6. 6 tool calls to the Mongo database. And then it finally decided to produce its results. Let's take another one, a look at one. So this is going to be a prompt template. So we have the same system prompt as before, but now we have a list of sports, decathlon, pole vault, 100 meters freestyle. And then we're going to use this prompt template here where we're going to put in the sports to do athlete biography material tied to Olympic sports in a text-oriented search over biography data, then cross-check that person with a structured Olympic tables. Now, this prompt is like a little cheaty because this particular prompt is telling the LLM like what kind of tools it should be thinking about using. This is actually a very good pattern with prompt templates, right? So a lot of times what you're doing is your user is not just sitting in an open chat box, right? If you're trying to automate some workflow, data might be coming in from anywhere. You might have structured JSON coming into this. And so prompt templates are a very good way for you to put input data into something a little bit more structured. And the structure here is giving hints or suggestions about what tools might be useful in this context. And obviously you have to have pre-knowledge of what tools were useful. A good place to put these prompt templates is in the MCP prompts capability, right? So this could have been a prompt template in the prompts capability, and then you could have used that prompt capability inside of your client, right? So depending on where you want to define those things, but that's exactly what this is doing. And so I would very much recommend that you guys put some other sports in this when you guys run this locally. But it's chosen the sport theme balance beam. It's still running? Still running. So, oh yeah, this exclamation R, I think this is choosing a random sport from this list of sports. I found several athletes associated with the balance beam theme from the biography search. Hungarian Margie Burundi, Amelia Birel, Zulema. I'm going to stop pronouncing things. And then a few summaries, and then a list of the specific athlete IDs referenced. So that's it for the tutorial. We only have 9 minutes left, but I would love for you guys to try this. Maybe start to edit some of these prompts that we ran through here, or you guys can feel free to go through and try some of these problem sets that are in the bottom of the notebook. And I'll be up here for if you guys have any questions. Yeah.
So the tools that you've added here are database sections, correct? So if you wanted to access an API, what things does the API need to have? What attributes? Is there something that you need to do to decorate the API in order for it to be a tool that's callable by the MCPs?
Yeah. So we are technically using an API here.
LLM, I guess.
Yeah, so MCP Toolbox is the API, right? So MCP Toolbox is what's connecting to our database, and then we are calling MCP Toolbox. But if you want something that's, and MCP Toolbox is what knows about these queries. But if you scroll up here to this function definition, here, this is what we're passing to the LLM, okay? And this can be anything, right? So type, function, function name, function description, and then the function parameters. So this can be anything. Now, there are tool decorators in the OpenAI SDK where you can decorate a Python function, and the OpenAI SDK will automatically produce this JSON. And it will use the function name as the name here, and then the description will be the doc string, and then it will use the type annotations in order to get the parameters. So if you want to use just a bog standard Python function, there are OpenAI decorators that will produce that for you. There are also tools that will take a Swagger doc or an OpenAPI doc and turn it into this format. Or you can just write this yourself, right? So if you're just going to call your own API, all you have to supply is the name, the description, and the parameters to the LLM, but then you have to translate that into the API call that you're making. And really what MCP is doing for you when you're using like something like Notion's MCP or GitHub's MCP, you're using these services, it's just providing this information to the LLM, right? And then when you get the call or the request to make a tool call, then the MCP server is also providing access to that tool, either indirectly or directly. So you can sort of think of like the GitHub MCP server as this definition for the GitHub API, if that makes sense.
What about security to connect to like on-prem networks like SSO? You embed that into tool call.
You can embed that into the tool call, but remember, you're in control of the tool call itself, right? So we didn't quite get through the tool loop function here. But this is the chat with tools function. So we're getting the max rounds, we're creating the client, we're creating our initial messages, setting some input and output limits. Then we connect to the MCP Toolbox client to get the tools right here. And so we're asking it to load the tool set, in this case, combined. Remember, we defined this tool sets, Postgres only, Mongo only, combined. So we're doing combined here. We're getting the tools by name. This is doing the mapping of the name to the tool call function. Here, we're translating that into that JSON struct that we have to put into the OpenAI definition. And then here, we just loop, we do at most 16 rounds. And for every round, we call the model. We look at the response. If the response has a request for tool calls, then we are going to call tool and append tool outputs, right? So this function, I go to definition. Call tool. This is going to get the arguments from the LLM or an empty dictionary for no arguments. And then it's going to call that function with the arguments, right? So this is actually that call. So any security happens right here, right? We're actually making the call ourselves. And if you need to do a check to make sure it's okay, if you need to do any escaping, if you need to do any prompt injection protection, this is where that security would happen. In terms of our data access controls, we have no security between this client and the MCP toolbox, but you could add security there. We have no security between MCP toolbox and the database itself, right? Because we're giving the credentials, but we could give it a role that only has access to part of the schema or some of the schema, so you can inject security there. But like I said at the beginning, it is 100% up to you. None of this does security natively. None of it does it on your behalf. There's no guardrails unless you set them up. But you at least do have control, right? The LLM does not go by itself to the tool. It has to come through you and your client.
Big picture question, and I'm part of the way there probably, but it might be helpful for you to hear you kind of restate. So there's a lot of scaffolding here, more than I expected walking into the. Why is this better than just making direct calls to with a SQLite Python package or whatever directly to these sources? What is this layer of abstraction supplying for me?
Well, that's a very interesting question. So we are doing a lot of scaffolding here. Usually things aren't quite so coupled as you see them here, right? So, in some of the bigger projects that we're working on, right, we have our clients, but our clients are kind of all over the place with this tool call stuff. And the clients don't necessarily define what they should be able to call, right? That definition is coming from the MCP toolbox in the YAML. So the first step is we're saying, here are the tools that we are allowing our LLM agents to use, right? That search by countries, look up biographies, et cetera, et cetera. Those tools just exist. That's a separate problem from the now I want this specific LLM client to be able to do X or Y or Z. So if you removed the MCP toolbox component and you just did the call yourself here, one, the client would be managing all of the database connections, right? So you don't have that security. Two, the client would be the one that's dictating what's allowed and what's not allowed on the database side. And three, two different clients might use two different descriptions and parameters for their call to the database. And so that might lead to uneven results, right? So this is a separation of concerns architecturally, where what the tools are is one concern, what tools we want to use is a separate concern, and then the connection of those two things is completely independent of it.
All right, so that's all the time we have for questions. Thank you, Ben.